Okay, we're recording. So we're going to start Unit D curve sketching with a fairly simple idea. It's the idea where we should be able to determine where on a function the function is increasing or decreasing. And here's just a typical curve of some sort. We're going to call this point in the curve right here um, having a coordinate of x1 and a y coordinate of f of x1. And this point here will have an x coordinate of x2 and a y coordinate of the function of x2. And we can say this rule. In general, a function f is called increasing on interval I. Oh yeah, we're going to call the distance between x1 and x2. Hang on, my pen doesn't seem to want to work yet. Even my pen's sleepy this morning. There we go. We're going to call that interval I. And in general, a function f is called increasing on interval I if the y value, so that's f of x1, so the y value of the first one on the left is smaller than the y value of the point on the right. So a function f is increasing on interval I if the y value on the left is smaller than the y value on the right, and I'll make that more clear here, whenever x1 is less than x2 in the interval I. That's an I. There. In other words, just to put this into kind of more plainer English, if going left to right, this point is higher than this point relative to the x-axis, then we say we have an increasing function. We have a decreasing function over interval I if f of x1 is greater than f of x2. So, and again, that's going from left to right. Here's how I say we're going from left to right. Whenever the first x coordinate is smaller than the second x coordinate. So if this function had been such that the first point was higher than the second point, I have a decreasing function. Like for example, I'm definitely decreasing from A to B, and I'm decreasing from C to D. Okay. So, of course, we shouldn't necessarily have to be able to rely solely on graphs to be able to look at them. We should be able to do a test. And the test for increasing or decreasing functions is where our calculus comes in. If the first derivative of the function is positive for all x, then it's increasing on all of the x values on that interval. And if the derivative is negative for all of the x values in an interval, then you could say that the function's decreasing on that interval. Let's do some examples where we don't necessarily have graphs to look at. Find the intervals on which the function f of x is equal to 1 minus 5x plus 4x squared is increasing and decreasing. So the first thing we're going to do is we're going to find the derivative. So I'll give you a second to copy that example down and then find the derivative. Okay. And while you're doing that, I'm just going to do a couple things here. Oops, sorry. I'll get that out of your way in a second. I just need a tab over on my other screen here. Sorry about that. Okay, was that enough time? Your derivative, of course, should be negative 5 plus 8x and we realize that the function f will be increasing according to our test rule here in the little note when, when that derivative we just found is greater than 0. So I'm actually going to do some algebra here and say f will be increasing when this derivative is greater than 0. And so to solve that, I'll have to add 5 to both sides of the inequality, divide both sides of the inequality by 8, and there we have it. Okay, so I'll say, therefore, f is increasing over the interval from greater than 5/8. So I'll say from 5/8 to infinity. Okay, similarly, if I were to take that derivative and set it to be less than 0, again, I'm going to get the same answer. X will be less than 5/8. And I would say then that therefore f is decreasing over the interval where x is less than 5/8, so I'll say from negative infinity up to 5/8. And make sure you understand that these brackets here have to be curved, because at the point 5/8, think about it, at the point 5/8, that's where the slope is 0. So what does that mean? Well, you're not increasing or decreasing if you hit a maximum or a minimum, if you hit a peak. Let's take a quick look at the graph of this, just to kind of make sure that this is making sense to everybody. Let me just drag her over here. There we go. So there it is. It's a parabola. And this maybe answers another question I should have asked here. So you could look at this and go, well, how do you know that this is the only interval it's increasing? How do you know further on it doesn't start increasing at another interval? Well, that's where I have to realize, oh yeah, I know what the shape of a parabola looks like. It only gets to turn around and change directions once. And so it's important that I know that. If I do graph it, again, you can really see that on the graph. So here's that 5/8, which is 0.625. That's where it stops being a decreasing function and it starts being an increasing function. And of course, if I show you the derivative there, well, the derivative there means that that's right where, at that 5/8, that's where the slope is positive after 5/8 and it's negative before 5/8. So that supports my answer that I came up with for this one. All right, let's do one that's a little more complicated. Let's move on to a cubic. Now, a cubic gets to change directions twice, so there can be more than one interval where we're increasing or decreasing. But we start it the same way. I'm going to run out of room on here, so you're going to need, if you did print this off, you'll need maybe the back of the page or something. So we start this the same way. We're going to need the derivative. So I'll give you another minute here to copy the question down and do the derivative. And while you're doing that, I think I might get the next graph kind of ready. Let me just move that out of the way for now here. Okay, was that enough time? So you should have 3x squared plus 12x plus 9. Okay, so I need to figure out where this thing is positive and where this thing is negative. And what might be useful is, of course, then to know, well, where is it 0? And then I'll split this into intervals between all the places where it's 0. So let's do that. We're going to find that by factoring. So first of all, I notice there is a common factor of 3. And then I get a quadratic trinomial that I can factor. So this thing has zeros, or x-intercepts, at x equals -3 and x equals -1. And so I basically kind of split the function into, I'll say, 3 intervals. I know that because it's cubic, it can only change direction twice. So I'm basically splitting it up into 3 intervals. I'm splitting it up into the intervals where, first of all, we go from -infinity to -3. Then we go from -3 to -1. And then we go from -1 to positive infinity. So I'm going to try to consider what this thing is doing over those 3 intervals. And to do that, I'm going to make myself a little interval chart, to track my intervals here. So let's see, what's this going to look like? I'm going to make an interval chart. So I'm going to say interval, and then I'll put these 3 intervals down. So I'll write them in the other notation too. I'll write them in set notation instead of, this is actually interval notation that I've written them in, but if that's not as familiar to you as this, I'll write it this way. So this, how do I write this in just regular old set notation? I say, well, obviously if I'm starting at -infinity and then going up to but not including -3, I'd say x is less than -3. So there's my first interval. Now, what is happening? I need to find out what the overall function is doing. Is it positive or is it negative? And if it's positive, it's increasing because that would mean its slope is positive, which means it's going up. So my end goal here is to figure out what the actual function is doing. Is it increasing or decreasing? But to do that, I need to know if f primed of x is positive or negative. And to know that, I have to figure out what these factors are doing. Now, there are actually 3 factors here, right? There's the number 3, there's x plus 3, there's x plus 1. Now, 3 is always a positive, so I don't have to worry about that. But x plus 1 could be positive or negative, depending on what kind of number you put in for x. And x plus 3 could be positive or negative, depending on what kind of number you put in for x. So, test a number. X is less than -3. Pick a number that's in that interval. How about -4? That makes sense, right? So -4 plus 1 is -3, so that makes that a negative. -4 plus 3 is a negative, and a negative times a negative is a positive. So I have a positive slope from -3 to -infinity. So therefore, the function is increasing over this interval. Okay, let's do the next interval. So the next interval is when x is between -3 and -1, right? This interval right here. So pick a number between -3 and -1. How about -2? That seems reasonable. Does -2 make this factor positive or negative? Well, it makes it negative. Does -2 make this factor positive or negative? Well, it makes it positive. When you multiply a negative times a positive, you get a negative, so we are decreasing between those 2 numbers. All right, next. What if I'm dealing with this interval? Anything bigger than -1. Well, if you put a number bigger than -1 in here, you get a positive. If you put a number bigger than -1 in here, you get a positive. A positive times a positive is positive, so we are increasing. And again, you might be thinking, well, what happens if there's another different interval somewhere past -1? Well, again, I know that there's only 3 intervals to worry about because I know that a cubic can only change directions twice. Okay? So, next, I'll make a conclusion. Therefore, what was my actual question again? Oh yeah, I was supposed to find where it's increasing. Therefore, f is increasing in these 2 intervals here, right? Increasing, increasing. So f is increasing from negative infinity to negative 3 and from negative 1 to infinity. Let's see if the graph supports my reasoning. Since I did all this really without actually looking at a graph, I mean, I'm always kind of visualizing what a cubic looks like. But let's see if the graph agrees with us. Well, there's, oh, you can't see that. There we go. There's my cubic, and as you can see, there's my let's see, did I copy that right? X cubed plus 6x squared plus 9x plus 2. Yep, looks good. So here's my places where we turn around, right? At negative 3, at negative 1. Okay, so there's my 2 places where we change direction. So we are definitely increasing on the left side of that one, and we're decreasing between them, and we're increasing again after that one. So yep, looks like the algebra and calculus we did the trick. And if I were to graph the actual derivative, you'd see, right, we are positive up to that negative 3, and then we're negative between negative 3 and negative 1, and then after negative 1 we're positive. So remember that this purple line here is the slope of the green line. So we have a positive slope right up to the point where we hit this maximum, and we have a negative slope between the maximum and the minimum, and then we have a positive slope again after that maximum. So there we go. That's our first introductory lesson to intervals of increasing and decreasing in functions. So I've put a little assignment from your Chapter D booklet on the blog. Okay, let me stop the video. Thanks for watching.